Hello friends, welcome back to my channel. In this video, I am going to solve exercise question from book Topics in Algebra from chapter number 4, Vectorspaces and Modules. So question is, prove that the intersection of two subspaces of vector space V is a subspace of V. Before proving this result, we will recall some definition and concepts which we are going to use in our proof. So first concept is subspace of a vector space. Let V over F is a vector space and W is any subset of V, then W is a subspace of V if under the operations of V, W over field F is itself a vector space. Next theorem, let V over F is a vector space and W is a subset of V, then W is a subspace of V if and only if number 1, 0 vector is a vector in subset W, and number 2, for all vectors W1 and W2 in subset W, and for all scalars alpha beta in field F, we have the linear combination alpha W1 plus beta W2 is a vector in subset W. Now we are ready to prove our result. So proof, let W1 and W2 are two subspaces of vector space V over field F. Now we have W1 intersection W2 is collection of all those vectors U in vector space V such that U is a vector in subspace W. Similarly, U is a vector in subspace W2. Now note that since W1 and W2 are both subspaces of V, 0 vector will be a vector in both the subspaces W1 and W2. So 0 vector will be a vector in set W1 intersection W2. Now consider two vectors, say U1 and U2 in W1 intersection W2. Now since U1 and U2 are in intersection of W1 and W2, we have U1 and U2 are both vectors in subspace W1. Similarly, U1 and U2 are both vectors in subspace W2. Then for all scalars or for any two scalars A1 and A2 in field F, we have the linear combination A1U1 plus A2U2 will be a vector in subspace W1. Similarly, A1U1 plus A2U2 will be a vector in subspace W2. Now since this linear combination A1U1 plus A2U2 is a vector in both the subspaces W1 and W2, I have written reason here. Since this linear combination is a vector in both the subspaces W1 and W2, we have the linear combination A1U1 plus A2U2 will be a vector in intersection of W1 and W2. And so by this theorem, we have W1 intersection W2 is a subspace of vector space V, and this proves our result.